uppercase C is 50, which means that lowercase c is x, A is 100, and B is 200. If it helps you to write out the formula at first, totally write out the formula. The formula is c squared equals a squared plus b squared minus 2ab cosine of c. So it's a recipe and we have the ingredients. I'm going to plug that all just directly into my calculator. 100 squared plus 200 squared minus 2 times 100 times 200 times cosine of 50. And I get that x squared is equal to 24288.5. Take the square root of that. Scrolling up, I press enter, and it comes down, and I get 155.8. Doesn't tell me, so I'm going to do 3 sig figs. So 156. I'm assuming kilometers because I don't remember. Aha, kilometers. All right, the bearing, now we need to find the bearing it must travel on to return to its original port. So let's redraw the drawing. A, B, C. If this guy is 50 degrees, actually, let's break it up in how we had it before, with north, south, east, west going on at each angle. So remember that this was 150, this was 30, and then this was 20. So just trying to remember what all of those different angles are in there. We can now do that for angle A as well. For angle A, we know that this guy is 20. We can solve for this angle right here, but I don't know if that's going to be helpful yet. So I'm going to actually not do that right now. What I am going to do next is talk about going on here. We need to solve for from the north, right? So we're going from here all the way around to here, and we want to solve for that angle. I'm going to look back up here to try and get some good knowledge going on. I know that alternate interior angles, this guy right here and this guy right here, are the same angle. So those are going to be, because those are alternate interior angles. So those are going to be, that's guys right there, is going to be 30. So I think if I solved for this angle right here, then I could subtract 30 and x from 360 and then solve for that bearing angle. It's a big puzzle. There is no same process that you do every single time. You have to piece it together, draw it out, and figure out what relationships are going on in here. And that's just all up to you. It's up to you to be able to puzzle it out. So practicing these problems and doing it over and over again, noticing the patterns, knowing how you're supposed to draw it is part of the way. And then it's up to you to kind of grasp that knowledge and play around with it until you get it. So we need to solve for angle X. Now that I have a plan, I might do a new diagram to help me just focus for a second. I want to solve for X. I know that this is 100. I know that this is 200. I know that this is 50. And I did just solve for the other side length. I got 156. I know it wasn't exactly 156, and I know that that number is saved in my calculator. So I'm going to make sure to use the exact value that's in my calculator. I could use law of cosines here. I'm not going to. I'm going to use the law of sines instead. So I'm going to do sine of X over its opposite side length, which is 100, equals sine of 50 divided by its opposite side length. I'm going to multiply both sides by 100. So 100 times sine of 50 divided by that 156 number, which is saved in my calculator. And so I get sine is equal to 0.4915. And then I'm going to take the inverse sine of that. Sine to the -1 of that value. And I get that X is about 29.4 degrees. So in order to find my bearing, remember going back to this diagram, that in order to find my bearing, I need to take 360 and subtract out 30 and X, and then whatever angle is left is how much I have to turn from your perspective all the way around. (360 minus 30 minus 29.4. I'm going to scroll up for that 29.4 number, and I get 300.56 degrees. Bearing always is 3 significant figures. So we would have to do 301 degrees.